In this example, we're going to try and calculate a dot a plus b plus c, and we've been given a diagram here with a triangle in it. We've also been told the magnitude of a and b and c. We need to remember the formula here, which is in the formula sheet anyway. So let's have a look at this. We've got a dot a, using our properties of scalar products, using your kind of algebra qualities. So a dot a is the same as magnitude of a squared, a dot b, and a dot c. So magnitude of a squared here. And then what we're going to do is we're going to write a dot c first, which is magnitude of a, magnitude of c, cos of the angle in between. Now, the reason I'm doing the a dot c first, and you don't need to do this, you can do it that way around, but a dot c first, I'm doing that because the vectors point away from the angle, and that's the situation we want when we're multiplying vectors. But if you look at a dot b, then a dot b is nose to tail. We don't want that. We either want the vectors both pointing in or both pointing out. So flip one of them round, so that's going to become negative magnitude of a, magnitude of b, cos theta. Now you could have the takeaway up here and the plus at the end. It doesn't make a difference. I've just done it this way around. So magnitude of a squared, that's going to be 2 squared looking up here, plus magnitude of a times magnitude of c, so that's going to be 2 times 2 root 3, and then cos of the angle in between a and c, which is 30. And then we're going to have a takeaway. But be careful here with the takeaway. Some people forget to do that. Then they forget the idea of the vectors pointing into the angle or both pointing out. So magnitude of a, magnitude of b, 2 times 2, and the angle in between a and b, if you look up here, this angle here is going to be 120, since 30 and 30 is 60, and you add 120 to make 180. The angles in a triangle always add up to 180. So cos of 120 there. So if we can resolve all this, then we've sorted it, we've done it. So 2 squared is 4. 2 times 2 root 3, that's going to be 4 root 3. Just take your time with this. And cos of 30 is root 3 over 2. Take away 4 multiplied by, right, cos of 120. Now, this is the way I would look at this. Cos of 120 is round here. So if you're thinking about what the relative acute angle is, it's going to be 60. So it's the same as the cos of 60, and then we decide if it's going to be a plus or a minus. And because we're in the sine quadrant, cos is negative. So really what we're looking at is negative cos of 60. So that's what that is the same as. And that's negative a half. Negative cos 60, negative a half. Okay, so 4 plus, now if you multiply 4 root 3 by root 3 over 2, and what you're effectively doing is you're doing 4 root 3 over 1 times root 3 over 2. So you're going to get a root 3 times a root 3 in the top, which is just 3. You can times that by 4 and get 12, so that's going to be 12 over 2 basically. You can have it like that, I suppose, but that's what it works out as, 12 over 2. Now we're going to end up with 4 times negative a half here, so half of 4 is 2, but that's going to be negative 2, and you take away negative 2, you get a plus. So that works out as 12. 4 plus 6 plus 2. That's the final answer. Now just before we stop, there is another way to do this, and I'll show you that now. So you can go in with this idea here. Now I'll do that a bit slower actually. Now, because you've got a plus b plus c, if you look at the diagram, then a plus b from the earlier vector work is just the same as c. So this bit here can be rewritten as c. So that journey from a to b is the same as c. So this bit in the bracket's really just c plus c. And that can be written as two lots of AC, A dot C plus A dot C, so there's two lots of them. So if you work 2 times A plus A dot C out, magnitude of A times magnitude of C times the cos of angle in between. A is 2, C is 2 root 3, so 2 times 2 root 3 times the cos of the angle in between A and C, which is 30. Cos of 30 is root 3 over 2, so we're going to have 4 root 3 times root 3 over 2. We're nearly done. Same idea here. You're going to get 4 times 3 over 2, so that's going to be 6, and you're down to 12. So just a different way of doing it, but equally as good.